In this video, we're going to look at solving some word problem systems of linear equations. I'll look at two examples here. And the first topic is solving a word problem using a system of linear equations of the form ax plus by equals c. Our example says a store is having a sale on walnuts and chocolate chips. For 2 pounds of walnuts and 3 pounds of chocolate chips, the total cost is $12. For 6 pounds of walnuts and 5 pounds of chocolate chips, the total cost is $30. Find the cost for each pound of walnuts and each pound of chocolate chips. So what we're looking for is the cost. When I'm setting up a system of equations, the first thing I want to do is identify my variables. So I'm going to let x equal the cost of 1 pound of walnuts. So x is representing the cost per pound of walnuts, and I'm going to let y equal the cost of 1 pound or cost per pound of chocolate chips. So identify your variables first. Now you want to set up a system of equations. For 2 pounds of walnuts, so that would be 2x, and 3 pounds of chocolate chips plus 3y, the total cost is $12. For 6 pounds of walnuts and 5 pounds of chocolate chips, so 6x plus 5y, the total cost is $30. And now you pick your method of solving this. You can solve by substitution, you can solve by graphing, you can solve by elimination. I'm going to go ahead and solve by elimination. I'm going to go ahead and eliminate the x. To do that, I'll multiply the first equation by -3, distribute that -3, and so my system becomes -6x minus 9y equals -36. Second equation is 6x plus 5y equals 30. Add them together, the x's cancel. -9 plus 5y equals -4y. -36 plus 30 gives me a -6. So y equals 6/4. Now I'm talking about a cost, so I don't necessarily want a fraction. I want to go ahead and get the actual cost per pound. So 6 divided by 4, you could go ahead and put that into your calculator. And we have $1.50. So the cost per pound of chocolate chips is $1.50. So for cost for each pound of chocolate chips, that's where I would put in the 150. All right, so now to solve for x, I'm going to take this y value. This is my y, my cost per pound of chocolate chips. And I'm going to plug it in to either of my original equations. So I'll go ahead and just use the first one, 2x plus 3y, but y is $1.50. So 2x plus 3 times 150 equals 12. So that becomes 2x. I said 12, but I wrote 15. So let me fix that. All right, so I get 2x 3 times $1.50 would be $4.50. So 2x plus 4.50 equals 12. Subtract 450 from both sides. So I'll do 12 minus 4.5. So 7.5. So 2x equals 750. Divide by 2, and I get x is 7.5 divided by 2, so 375. So the walnuts are 375 per pound. So up here for the cost for each pound of walnuts, that's where I would put the 3.75. Now checking your answer really only will help you if you've set up your equations correctly, but you could just go ahead and say, okay, for 2 pounds of walnuts, I'm going to pay 2 times 150. Actually, the walnuts are 375. So 2 times 375 and 3 pounds of chocolate chips. So plus 3 times 150, the total cost is $12. So that one worked out. And then for 6 pounds of walnuts, so 6 times 375 plus 5 pounds of chocolate chips, that would be 5 plus 150. The total cost is $30. That one checks out. So those costs, 150 per pound for chocolate chips and 375 per pound for walnuts, make sense. Let's look at another example. This is solving a word problem using a system of linear equations in the form y equals mx plus b. An air traffic controller is tracking 2 planes. To start, plane A is at an altitude of 5,000 feet, and plane B is at an altitude of 3,866 feet. Plane A is gaining altitude at 45.25 feet per second, and plane B is gaining altitude at 65.5 feet per second. So this is a rate of change, feet per second. So that's going to translate to a slope. 45.25 feet per second, that's also a rate of change. So that's going to translate to slope. To start, that's going to indicate the y-intercept. We want to know how many seconds will pass before the planes are at the same altitude and what will their altitude be when they're at the same altitude. So I'm going to go ahead and set up 2 equations, A and B. For plane A, I'm going to let the altitude be y. And for plane A, the slope is 45.25. So I'll have 45.25x. Plane A started at 5,000 feet, so I'll have plus 5,000. For plane B, the slope is 65.5, so I'll have 65.5x. And plane B started at 3,866. Now you can go ahead and solve this using substitution or graphing. Those would be the easiest 2 for this instead of elimination. because if you are solving, you can actually just set the two equations equal to each other. 45.25x plus 5,000 equals 65.5x plus 3,866. And then you can go ahead and solve that equation. So if I move the 65.5x to the left side, I'll subtract it. So minus 65.5x. Move the 5,000 to the right side. So subtract 5,000. I'll have 45.25 minus 65.5. So negative 20.25x. Negative 20.25x equals 3,866 minus 5,000 is negative 1,134. And I want to divide both sides. I can do answer divided by negative 20.25. And I get 56. So divide both sides by negative 20.25. And I get x equals 56. X is representing the seconds. So this will be 56 seconds for the first part. And then what will the altitude be? Go ahead and plug in 56. So y equals 45.25 times 56 plus 5,000. Or I could plug it into the second one. Y equals 65.5 times 56 plus 3,866. I should come up with the same altitude for the two planes. So let me plug that in. 45.25 times 56 plus 5,000. I get 7,534, or 65.5 times 56 plus 3,866. I get the same altitude, which tells me that 56 was the correct number of seconds. So for the altitude, I would put 7,534. But they have to come out the same. Otherwise, I haven't actually figured out where the two lines cross. So I would say 7,534 feet. I want to make sure my units match up. Feet, seconds, feet, everything looks good. Everything is either in feet or feet per second or seconds. So just checking the units can be helpful to make sure that the units match up with what you're finding in your final answer. So with these, you want to set up your equation. When they're in the form y equals mx plus b, once you've set up your two equations, you can just set them equal to each other to find the x value. With that first example, With the ax plus by equals c form, you can solve by elimination.